Hi, so today's demo is a mix of an Angular Elements demo and OpenAI's sentiment neuron, an RNN, a new kind of RNN for predicting sentiment, originally created for generating product reviews. So it's packs a lot of interesting stuff. First thing is that this is really, it looks like a regular responsive app, basically like a chat widget, but it's not. It's made of web components, right? And I've taken this example and I've modified it heavily, both to interact with the AI model server as well as to add functionality to it, change the way the web components are deployed to match the architectural criteria for reuse. And I'm going to just dive into it right now. So I'll show you the page source. This is just the body style. The web components themselves are the chat config element and the chat widget element. As you can see, they take two different places in the DOM. They're completely separate elements. They are just like any other HTML element, except they are custom elements. So the user-defined elements. I've taken the polyfill stuff that normally goes into Angular components, but because they're web component polyfills and there will be many web components, could be many web components on the same page, I've taken them out and put them in the global scope as scripts. Same thing with Zone.js, which micromanages the JavaScript event loop to do change detection, for if you're setting values with async callbacks like Ajax callbacks and things like that, or using RxJS, etc. RxJS is a different story, but if you're using async events, this intercepts and triggers change detection within Angular. It cannot be loaded more than once, so it's isolated outside of Angular. We put it in the global scope so that web components don't load it again and again. And then the chat widget, which is just like the custom elements, these custom elements, and their bootstrapping code and dependencies, all the Angular dependencies. It's not really that big. The chat widget, which is both elements, the chat config as well as the chat widget itself, they're not that big. Let's just take a look at the code here. So if we look at it's 285 kilobytes, but that's for the entire set of two components, the entire chat widget, and so basically it makes sense right now in version 7 with the Ivy renderer. The size is going to come down 10 times by 10 times. It's expected to each component will be around maybe 20k in size, and so if we put two components together, we're not loading the dependency twice but only once, and they should be about 20-30k together. That would make it make more sense for individual little components to be distributed as web components. But for now, with Angular 6, if you have a substantial component that's made of several other Angular components, and maybe you have more than one web component that work together, as we have here, the chat config and the chat widget itself, then it may make sense. It's a fairly complex component, right? It may make sense to package them as web components and distribute that way in one bundle. And the 285k in size, that's not optimized for production either. So it's could be maybe around 200k, and that's a small price to pay for great reuse. The fact that you could then take this, reuse it in AngularJS, you reuse it in React, reuse it in Ember, reuse it with Dojo, reuse it with jQuery. Basically, if you can throw it into any framework or in no framework at all, just the HTML, CSS, and a tiny bit of JavaScript or no JavaScript at all, and it can still work. Obviously, we need a couple lines of JavaScript here to hook up the. When you click this, it produces a theme change event. It's a custom DOM event that bubbles up and that's exposed on the custom element, and we basically listen to it as we listen to any other DOM event that bubbles up, from the parent, and then we we grab a reference to the chat widget, which is get element by ID. It's just a DOM element, and then we set its property, the theme property, to gray or red or blue. And when we do that, we also invoke an internal method to focus, and Angular 6 doesn't support custom methods on custom elements yet, but there's a workaround for it, a very simple workaround, which is used to use the setter functionality. And so these components, the advantage of web components is that they can be deployed anywhere, and you build them once, you use them everywhere, and you never have to build, refactor them again. Angular has gone from Angular 2 to Angular 4 to Angular 5 and now Angular 6, and the gap between Angular 5 and 6 has been abridged. Angular 5 only came out last year, and we already have Angular 6, and so Angular 7 is going to come out at the end of this year, and so it's kind of pointless to keep making components and refactoring them and tweaking them and making changes and different things to make it work for the next framework version. So it's better to build it as a web component, and then it's immune to change at that point. It's just isolated, and it will exposes itself as any other DOM elements, but a custom DOM element with custom props and properties and methods and attributes. And so it's really fascinating way of building components for the web, because for the first time we can have truly reusable components. So if you want to get more into it, I advise you to read the index-elements.html in the source folder for all the comments there, and I advise you to read the README, and I can walk through the code with you. But beyond that, let's get into the AI portion of it, which is really exciting as well. If we pick some examples of good, this is not from the training set. If we pick, this type of example, good review here, put it there. And because I don't have a GPU running in the back, in this machine, and QuickTime is running at the same time, eating up all the available graphics processing power, it's very, very slow. So on a third generation TPU, or on a Tesla, on an NVIDIA Tesla, I think it's called Tesla 100 or V100, it should work much faster. So this says, this review is positive. If it was negative, it was give it a negative value. Let's try a negative review. Let's see. I want to avoid trigger words like the major problem, as that would give it away and make it more obvious. I'm sure there are a lot of the negative reviews that were labeled had the word problem in them. So let's try to be more tricky. So this has the word great in it, and it has disappointed. So let's see what it comes up with. So it came up with a negative. So even though it says I thought it would be great, etc., so it's not really simple linear output of the key, dependent on the keywords. It's basically pattern recognition, right? It indicates that there is a relationship between sentence formation patterns, since this was trained to generate reviews, not to classify them originally, and sentiment. So the sentence formation patterns and sentiments are kind of related. There's a basic relationship between the two. At least that's what this experiment hints at. So anyways, the major topic of this is the web components, not the AI, so I'm not going to spend a lot of time poking around the AI, but I can say thank you, this does bode well for the future of AI. Let's see what it says. It gave it a positive thing, but it does not bode well for the future of React, since React team refuses to upgrade React to do what Angular is doing, which is, make it easy to produce web components. React can still consume web components, but there's some edge cases they could work with, and there are workarounds for them, but they're not being a really good player in the web component space. They're kind of shut down that whole discussion. And so let's see what it says there. Dies instead of does. It still got it right. It's kind of immune to small spelling mistakes because it's working with the overall sentence formation pattern. So that's the demo. I don't want to make it too long. Go to the GitHub repo and look through the files, and we'll be happy to go through those with you in extreme detail.